Let's start with something that sounds almost contradictory. Electric cars, charging themselves, not from the wall, not from a charging station, but while they're already in motion. Now, to be clear, electric vehicles don't create unlimited energy. That's not how physics works. But they do use a principle that, at first glance, feels surprisingly close to it. A principle that allows them to recover energy that would otherwise be lost and reuse it. And once you understand how this works, it changes the way you think about energy. Not just in cars, but in everyday systems. So today, let's break this down in a simple, practical way. What's actually happening inside electric vehicles? Why this endless power idea is misunderstood, and what it reveals about how energy can be used more efficiently. The hidden moment. Most people miss. Imagine you're driving an electric car. You press the accelerator, and the car moves forward. That part is straightforward. Energy flows from the battery to the motor, and the motor turns the wheels. But now imagine something different. You take your foot off the accelerator, or you press the brake. In a traditional gas-powered car, that energy, the motion of the vehicle, is mostly lost, converted into heat through braking, dissipated into the environment, gone. But in an electric vehicle, something different happens. What regenerative braking actually does. Electric cars use a system called regenerative braking. Instead of simply stopping the wheels using friction, the electric motor reverses its role. It acts as a generator. As the wheels continue spinning, their motion is converted back into electrical energy. That energy is then sent back into the battery. In simple terms, the car captures part of its own motion and turns it back into usable power. Not all of it, but enough to make a measurable difference. Why it feels like endless power. This is where the confusion often begins, because from the outside, it can seem like the car is constantly recharging itself, driving, slowing down, recovering energy, repeating the cycle. And while it's not infinite, it does extend the usable energy of the system. Instead of losing all energy during braking, some of it is recycled. That's the key idea. Not creating new energy, but reducing waste. The efficiency advantage. In traditional systems, energy loss is accepted as part of the process. Friction creates heat, motion slows down, energy disappears. But regenerative systems are designed to capture part of that loss, and even small improvements in efficiency can add up over time. For example, in city driving, where vehicles stop and start frequently, regenerative braking can significantly extend the vehicle's range. More stops mean more opportunities to recover energy. On highways where speeds are more constant, the effect is smaller, but it's still present. The bigger principle at work. So what's the deeper idea here? It's this. Energy systems don't have to rely only on input. They can also be designed to recover output. That's a different way of thinking. Instead of asking, how do we generate more energy? You start asking, how do we lose less of what we already have? That shift is subtle, but powerful. Why this matters beyond cars. Regenerative braking is just one example, but the principle behind it shows up in other places too. Industrial systems use similar concepts to improve efficiency. Mechanical systems are designed to reduce friction and preserve motion. Energy storage systems capture and release power in controlled ways. These ideas aren't new. They've been studied and applied for decades. But they're often hidden behind technical language or large-scale applications. So most people never think about how they might apply on a smaller, more practical level, bringing it back to everyday life. Now let's bring this closer to home. When you think about your household energy use, the focus is usually on consumption. Lights, appliances, heating and cooling. Energy flows in and gets used. But rarely do we think about how much of that energy is lost, or how systems could be designed to operate more efficiently, or maintain output with less input. And that's where this conversation becomes interesting. The misconception about powering everything. One of the biggest assumptions in home energy is that you need large amounts of power to maintain comfort and stability. Power the entire house, every appliance, every system. But in reality, during most situations, especially outages, only a small number of systems truly matter. Refrigeration, basic lighting, communication devices. These essentials don't require massive energy output. They require consistent, reliable support. And that's where efficiency-based thinking becomes valuable, from production to optimization. Traditional solutions focus on production, more panels, bigger generators, higher capacity systems. But there's another approach. Optimization, using energy more effectively, reducing losses, maintaining function with minimal input. It's not about replacing everything. It's about rethinking what's necessary. Why this idea isn't widely discussed. If these principles are already used in advanced systems like electric vehicles, why don't we hear more about them in everyday energy discussions? Because most consumer solutions are built around scale. Large installations, high output, centralized systems. Efficiency-based approaches don't always fit into that model. They're often smaller, more specific, focused on function rather than total capacity. But for many households, that's exactly what makes them practical. A different way to think about energy at home. Once you understand this, the conversation changes. It's no longer just, how do I generate more power? It becomes, how do I maintain what matters, with as little waste as possible? That's a more focused question, and it leads to more flexible solutions. Not extreme, not complicated, just practical. The real takeaway electric cars don't run on endless power. But they do show us something important. Energy doesn't have to be used once and lost. It can be managed, recovered, extended. And when you apply that mindset beyond vehicles, it opens up new ways of thinking about energy in everyday life. On this channel, we explore those ideas step by step. No hype, no unrealistic claims. Just clear, grounded explanations of how energy systems actually work, and how households can think about them differently. In upcoming videos, we'll break down why traditional energy solutions don't always solve the full problem, what really happens during extended outages, how to identify the essential systems in your home, and how efficiency-based approaches are being applied in practical ways. If this kind of thinking is useful to you, subscribe to the channel. And if you want to explore a real-world example of how these efficiency principles are being used in a way that's accessible for everyday homes, there's a resource linked in the description. You'll also find it in the first pinned comment. It connects directly to what we discussed today. Taking a concept that already exists in modern technology and understanding how it can apply in a simpler, more practical context. Subscribe, check the link in the description or the pinned comment, and I'll see you in the next video.